In this lecture, we're going to see one of the applications of what we've studied so far about matrices. So we studied about reducing a matrix to a row echelon form, right? A row echelon form. So in this case, we are going to see how to solve this system of equations. So three equations, three unknowns and three equations, a linear system of equations using matrices. So what we do is we write the coefficients of x, y, and z as a separate matrix A. Okay, write it as a matrix A. So the matrix A is nothing but the coefficients -3, 2, 6, 5, 7, -5, x, sorry, 1, 4, and -2. And we write a column vector x, and that column vector has entries x, y, and z. Okay, x, y, and z. And then another matrix B, which is another column vector, which will have the constants 6, 6, 8. So this now I can write as equivalently in the form of matrix notation in the form A x equals Ax equals B. Okay, Ax equals B. Now what we are going to do is we're going to reduce this A matrix to a row echelon form. So A matrix using elementary operations to row echelon form. So once we do that, we'll be able to solve this system of equations. Okay, so when you reduce the, I taught you how to reduce it to a row echelon form. You have to pick the pivot and do elementary operations till you get zeros in till you get the row echelon form. We had studied about the row echelon form, so I'm not going over that now. So when you reduce a matrix to a row echelon form, the matrix A matrix that you get, okay, 1 minute, you actually have to reduce the matrix A comma B. It's called the augmented matrix, and the augmented matrix will actually be both the matrices combined, A and B combined. So -3, 2, 6, 5, 7, -5, 1, 4, -2, and the B matrix. So this is your augmented matrix. This is the matrix you have to reduce the row echelon form. Sorry about that. So when you reduce the row, this matrix here, augmented matrix to row echelon form, which we had studied how to do, you get this matrix. Okay, what you get is essentially this matrix. One, 4, -2, 0, 1, -7, 0, 0, 1, 8, -4, and 1. Okay, so now you can separate it and write out. This part is the A matrix, right? This part is the A matrix and this part is the B matrix. So separate it and write it out. So once you separate it and write it out, you will get 1, 4, -2, 0, 1, -7, 0, 0, 1 multiplied by x, y, and z. This is equal to 8 -4, 1. So when you multiply this out, you will get this equation. First equation you get is this equation. When you multiply this row and this column out, second equation you'll get this equation. When you multiply this row and this column out, you get the third equation. Okay, third equation. So you get it. So now we can easily solve. So from you already have z value. Substitute z value here. You can solve for y. and substitute values of y and z here, you can solve for x. Okay, so that is very simple. So y is here nothing but y is equal to minus 7 into 1. Okay, that will be minus 7 itself. So y is equal to 7 minus 4, which is equal to 3. So just substitute values of y and z into x, and now you get the value of x. So here you can easily solve this system of equations. Now there is another way to solve this system of equations, which is you had written out the matrix A x equals b. Now multiply both sides by A inverse. So A inverse, so doing the same operations on both sides doesn't change the equation. So A inverse into A is nothing but the identity matrix I. Okay. And identity into any matrix is the matrix itself. So X is equal to A inverse into B. So so this is the inverse. So when you multiply the inverse by um, the any number multiplied by its inverse will give you 1. So similarly, any matrix multiplied by its inverse will give you the identity matrix I. So here you get this. So you find A inverse and B, multiply together, you will get the values of x, y, and z. But what is A inverse? A inverse is this. The formula for A inverse is the adjoint of A. So adjoint of A divided by the determinant of A. Okay, determinant of A. So adjoint of A is nothing but the cofactor matrix. Okay, the transpose of the cofactor matrix. So we studied about what is the cofactor. That's why I did all the terminology before. If you're feeling a little lost, go back and review it. I taught you what the cofactor matrix is. So the cofactor matrix, it's the transpose of the cofactor matrix. So cofactor matrix has all entries are the cofactor elements. Okay, the cofactor element, it's made up of the entries of the cofactor elements, and you take the transpose of the cofactor matrix, you get the adjoint of A. And A inverse is simply the adjoint of A divided by the determinant of A. So you can simply solve for x, y, and z using this method also.